For this video, I'm going to use Google Sheets for linear modeling. This one says that the water level of a river is 34 feet. So in this case, it starts out at 34 feet and it's receding. Now receding means going down. You will be subtracting. What's happening is here you have something that starts out at 34 and then goes down. That's where the subtraction comes in. It's going down at a rate of 0.5, half a foot per day. All of these problems will be like this in that you have some rate somewhere, like 3 per inch, 4 per minute, or something like that. That's the part that's going to have your slope with it. I have my 0.5 and then per day. That's the part that's going to have your x with it. So it's per minute. You have an x there, per hour or whatever. Your y is just going to be stuck out in the front. That's going to be your equation. Now the rest of the problem says write an equation for the water level L after d days. Your days are the part that's here, 0.5 foot per day. This is your day. That means your other letter is the L. This is the equation that they're asking for. In how many days will the water level be 26 feet? We can put 26 feet for the water level, just like we did on the other problems. We've got to figure out how many days it would be. So this plus 34 would move to the other side, so we would have minus 34 plus 26. Use your calculator if you have problems looking at this. If you don't have a calculator, just go over and search for the calculator on your computer. I can type minus 34 plus 26 equals negative 0.5 days. You will take your calculator and you would press 8 divided by negative 0.5 days. If we're dividing by 0.5, that's the same as multiplying by 2. If you do it on your calculator, you won't have a problem. My answer would be 16 days. This is the algebra that you're going to be doing, but you're going to need to get the equation first. It's a matter of reading what's happening. If this had said going up at a rate instead of a minus sign, we would use a plus sign. This next example we will complete using Google Sheets. We have a small store sells pineapples based on data for pineapple prices between $2 and $5. The store owners created a model in which a linear function is used to describe how the demand, the number of pineapples sold per day, varies with the price. For example, the $2, 80 pineapples means that at a price of $2 per pineapple, 80 pineapples could be sold on an average day. For $5, 50 pineapples could be sold. What is the rate of change for this function? So I'm going to go into Google, like we've done before, and I'm going to put my points in there. Next, we're going to highlight the points and select Insert Chart. We'll need to do a scatter plot. As long as I have 2 points, I can do this. So all your problems, you're going to have the 2 points. You're going to go to Advanced Editing, go down like we've done before, and pick Trendline, and select Linear. Also, tell it that you want the equation, so under Label, click Show Equation, and then click R squared. This will tell us how close to a straight line the points are on a graph. To find R, we'll go back to the main sheet, and we're going to need to take the square root. So I start typing equals square root. That function appears. Select it. Type in the 1, enter, and you get an answer of 1. This means that the points fit perfectly on the line. The equation is negative 10x plus 100. The way we're going to use this right now is the negative 10 is the slope, 100 is the y-intercept. We can make any kind of prediction now that we need to, which is what we're going to do. If I asked you how much would the pineapples cost, or how many pineapples would I sell if pineapples cost $3, I would substitute the 3 in for x, and I have y equals negative 30 plus 100, so y equals 70.